Alright, here we go. Ladies and gentlemen, quiet please. Alright, good morning. Today you do have a Delta Math. And today's pretty simple, nothing too challenging today. Notes are going to be quick, and then you may begin the Delta Math review for your test on Thursday. So make sure you know, test Thursday, and we are nearing the end, so close you can almost taste it. Okay. So today we've been talking about all sorts of special relationships within circles, and today we're wrapping that up. Tomorrow's the last day of notes, and today is very easy. We're working with the standard form of an equation of a circle, which is x minus h quantity squared plus y minus k quantity squared equals radius squared. This is a standard form of an equation of a circle. So if you see something that sort of looks like this form, it is the shape of a circle. Where does it come from? Well, it turns out that if you sort of get rid of some of the extra stuff here, it's really just x squared plus y squared equals radius squared. And what does that look like? What have we done? The Pythagorean theorem, yeah. It is, in fact, just the Pythagorean theorem. Leg squared plus leg squared equals radius squared, or hypotenuse squared. So it is just a play on the Pythagorean theorem. Most of math is just Pythagorean theorem, okay? So it's kind of interesting. So what happens here? I want to talk about the negatives in this equation. So it turns out whenever there's a minus in a formula like this, I want you to think opposite of h, or in this case, opposite of k, because that minus sign is technically telling you it's the opposite of the value of h when we have it in a formula like that. Well, it turns out when we have this form, the h and the k is the center, where HK is the center of the circle and R is the radius. Okay? HK, you'll notice the H is with the X, so that's telling you the X coordinate of the center, and the K is with the Y, that's telling you the Y coordinate of the center. But you need to think there's opposites in there. Okay, so we're going to be really, really careful. And the thing you really need to remember is that on your formula, this last number, what we're equal to, that constant, is the radius squared. All right? So we have to get back to the radius length. Okay, so we're going to be a little bit careful here. All right, so here, number one, this is in a standard form. And when you look at this standard form, you'll notice this says x plus 4. What do you suppose the center is?
8.
So should it be positive 4 or should it be negative 4? It's negative 4, yeah. It's always opposite, yeah. It is always opposite, just like when we double bubble and solve, the value turns to the opposite. So here, our x coordinate for the center is negative 4, and what's our y coordinate? Positive 2. All right, so it sort of always appears to be the opposite. Now remember, 25 is the radius squared. So we want to know, hey, what is being squared to get 25? 5 is being squared, so our radius is 5. R equals 5. So how are we going to graph this? It's pretty easy to graph these. We're going to plot the center. So the center is at negative 4, 2. So 1, 2, 3, 4 to the left and 2 up. So there's our center at negative 4, 2. And then from there, we're just going to do a north, south, east, west counting 5 units for the radius. So up 1, 2, 3, 4, 5. There's the radius length of 5. 1, 2, 3, 4, 5 to the right. 1, 2, 3, 4, 5 below. And 1, 2, 3, 4, 5 to the left. And then I'm going to do just the best circle that I can. And there we go. We've graphed our circle. All right. That's it. Pretty easy, eh?
How'd you get 5 of that?
So this, the constant on the end is the radius being squared. So we said, hey,
Oh, yeah.
what number squared gives us 25? All right. What's wrong with number 2?
The second one.
There's not another value of a yk? Can we put one in?
Yeah.
A 0, absolutely. So this one looks a little bit weird, but we can modify it to suit our needs. So I just went ahead and said, oh, well, if there's nothing there, it must be a 0. And hey, what number squared gives us that 4? 2. Okay, super. So now that we know that, what is our center going to be? Positive 7, 0. Beautiful. And what's our radius? 2. Good. And so to graph that, I'm going to graph the center. That would be 7 units. 1, 2, 3, 4, 5, 6, 7. 0 on the y-axis, so just 7 to the right. And then I'm going to plot my radius. 2 units up, 2 units to the right, 2 units below, 2 units to the left. And there we go.
Circle. That's not red. What is that doing?
All right. Questions so far? Pretty easy, eh? All right, let's look at number 3. What is our center?
3, negative 1.
Good. Positive 3, negative 1. What's our radius?
7.
Yeah, remember this is a number being squared, so the radius is 7. So we're going to plot our center at 3 units to the right, 1 unit down. So there's our center, 3, negative 1. And then count 7, north, south, east, and west. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7 to the right. 1, 2, 3, 4, 5, 6, 7 below. 2, 3, 4, 5, 6, 7 to the left. I think that's right. Yeah, all right. Oh, my circle's not awesome there. That was not a great circle. That's okay.
Fine.
It's fine. It's fine. It's fine. All right. Number 4. What's our center?
Negative 6. Negative 5.
Good. Negative 6 and negative 5. Change those signs because we are opposite values for H and K. And the radius would be 4 because 4 squared gives us that 16. Fantastic. So negative 6, negative 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Right there. And then the radius is 4. 1, 2, 3, and 4. All right. Raise your hand if it's pretty easy. So let me ask you a question. If they gave you the circle, would you be able to write the equation for it?
Yeah. Yes. Yes.
Yeah.
I can. Yeah.
Yeah? So you'd be able to find the center, and that would give you your H and your K, and then you could count your radius, right? Okay.
Oh.
All right, fabulous. Let's try a couple more here.
Okay. 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 Radius is
All right, let's identify. What is the center here in standard form?
5 plus 5 points.
5 and a 1. And then what's the radius?
8.
8, okay, because 8 squared gives you 64. Perfect.
I do -0.
You don't. There isn't.
It's just 0.
All right, what about number 7? What is the center? 0, -10. All right, 0, -10. How do we figure out, oh, this one's the diameter. I guess I need to figure out the radius. How are we going to figure out the radius for this one? Square root it. Very good. So we know that 42.25 is supposed to be my radius squared, so we're going to square root both sides. And so we get r equals 6.5. Beautiful. How do we find the diameter?
Multiply it by 2.
Yeah, times it by 2, and we get 13 for the diameter. Okay. This one's asking for circumference and area. What is the formula for circumference? 2 pi r. Very good. What is the formula for area? Pi r squared. These are formulas you need to have memorized, ladies and gentlemen. They are very important formulas. So once again, we can start by finding our center. What's our center?
-2, -9.
-2, -9. And remember, 196 is our radius squared, so how do we figure out the radius? Square root, okay, so what's our radius? 14, all right. And so now if we want circumference, what do we need to do? 2 times pi times 14 equals? 88?
Yeah.
Is it okay to just say 28 pi?
Yeah.
Yeah? Is that okay? That is like perfect. And we could approximate it if we wanted to. Good. All right. Number 11, what is our center? 3, -4. And remember, 81 is our radius squared, so what's our radius? R equals 9, and so then area is going to be pi times 9 squared, which would be 81 pi. Is that okay to leave it like that?
Yeah.
So it's easier, isn't it, than having to use our calculator? Okay. Do you have questions for me?
No.
This seems to be a very
That was ridiculously fast.
This is good.
All right.